Okay, people, let's just jump right into it. We're going to come back to Tong Li. We've got about 5 tabs I'm going to try to race through. So currently, we have the new release, all right, for CTS, Champlain Towers South, reference to this company that actually works for whom? The Condo Association. So don't think you're getting some profound great news. You're getting the Condos Association, WJE's buyers report. And what we have here is they're pointing towards the Tong Li, but they're not saying his name. They're just flirting all around it, but not his name. Let's take it from here, and then I'll jump to Tong Li.
Have not actually been considered by the original engineer. Another thing that was quite interesting is that when we're looking between the original drawing set and the recertifications.
So as you look at the scale up, the color coding, as designed planters, a little darker green, lighter green, additional planted area not as designed, and that would be here, 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 and here. I want you to take note of one thing. He doesn't know what the F he's talking about, the additional loading, because these planter boxes are loading directly on top of a column. All right, this planter box, not this one, but it wasn't engulfed in the accident. Of course, ultimately everything was, but it didn't go this far over. This is on the planter box. Over the column. The column stayed proud. It was the deck failure, all right? It's the deck failure around it. He's also going to state, just for clarity, guys, jump into where I'm going here, that this deck did not have a control joint. He's going to state that in the latest release. This is the release before. I didn't finish this release off, so maybe I'll state it in here also. But I'll cue that up. I got it queued up, ready to go if I'm correct. So these plants are directly on top of here, directly on top of columns. All right, over here we have, this is the one that the K13 deal that signifies the original signals, there's more signals than that beforehand, but the signals with the photographs with the cracked planter box signals that shit was going to happen. Except for he's going to point over here and wait till you see how simple. I will call this out. Yes, it does have to include part of this, but it was not the original part. I'll give you the hint. And I'll talk kind of condescendingly on this one because it deserves it. It's the only way to communicate this way. It's like, what part of you don't understand that there's a butterfly between here showing deflection, and yet he's going to put deflection from here to here as the starting point. They are in their latest release. It's asinine, all right? Asinine. So Gary and Matthew, you get a failure. All right, you don't get a partial failure. You get a failing grade on this. A failure grade on this. You're ignoring the data. You got so much bias against you, or with you, or lack of skill or knowledge that you're ignoring that there's a butterfly here indicating that. You have the butterfly, the deflection starting from here to here. Not indicated by any other engineers, but by the engineers that did the inspection. But indicated by the failure, that we see the failure down the middle. If you have it here and here, we would have a butterfly this direction. All right, this is sagging, and this is sagging. We would get a butterfly this way. But if our sagging is between these these points, then that would indicate the first part to start deflecting the most. To start pulling the drape down. Pulling it down, so a drape. But think of it as a drape. The deck is a drape. Pulling it downwards. I'll give you a diagram in a moment, but let's listen to the first few seconds of this.
Repair set and just photos in general of the site. We noticed that there were a lot more planters than originally designed, and so that's something to really note. planters can be quick.
And I think this is on Tong Li. But let's not talk about Tong Li, because who hired Tong Li? I believe the condo association hired Tong Li. So it's kind of, wait a minute, are you saying that? And not in this report yet do I hear him talk about vibration from next door. But let's listen on.
Heavy, and so again, another spot where there's potentially additional load on this deck.
And let's take my man Matt with the sprinkler system. Never once did they talk about him, as far as I know yet, and or the other report or NIST. So why are they throwing the guy that did the sprinkler system, alarm system rather? Why are they trying to throw him under the bus when it came down to the court, along with the guy that rented a backhoe? Really, he rented the backhoe to you, and you threw him under the bus? It was just a money grab, as I stated a long time ago. They're just going to make all the money back from insurances. And they did. And now look what they're doing, collapsing the condo economy down there, which they kind of should, because these buildings with the plate slab construction are, for the most part, cycling out. Sorry, I'm moving my chair around.
The recertification engineer did a lot of work in terms of reorganizing some areas of the building. And in that sense, they reorganized the entrance ramps, and
it's coming up to this
they needed
zone.
to do some analysis related to the framing.
Wait
and
for
so they ran some calculations in a software called SP Slab, and added some flexural bars.
This is what it was going to be, the repairs.
Along column line T, for example, and some other locations as well. Notably, though, the results of their punching shear analysis come out to show exceeding values for every column along that column line T. One thing we do know is that there is no record in their file, essentially, of any calculations related to the pool deck area. And
so no record of any pool deck area calculations. But yet they did do a column core sample out there at the pool deck. We know that. But there's no record of the calculations.
So it's a little concerning that some of these were exceeded, and you'll see with some of the other distress coming later that there is a concern that this was somewhat missed.
And this is where they're going to go from here, which is, I believe, is here to here. This is Matthew and Kev and Gary together. And this might be Gary talking right now, being interviewed. And I want to point out that there's a driveway in the background. All right, that's the driveway ramp going up. So we're looking at the back side of it, which puts us here, looking that direction, the ramp behind us. And so what do you observe? You see the water on this side, the penetration on this side. Wait a minute, wait for it, guys. I'll give it to you now. Observe the efflorescence, the blistering paint, the indications of water over time, creating this maybe salts right here. This efflorescence. But it's on a diagonal. It's on a diagonal. K is here. All right, it's here. This is indicating in front of the column. And let's go back. If I knew the plumbing setup, I'd be able to tell you more accurately. But it's indicating like that, and it's out of our sight. And then this would happen from a deflection from the butterfly here, bending over. And we can't see beyond our head here, but I mapped this before, and we see a lot of it here. This is just all fracturing to individual pieces.
Column L13-1 and column K13-1 shown in the pool deck area also showed some signs of significant distress related to punching. And so we'll focus here first on column L13-1, which is circled to the right. And it's kind of in the field of the pool deck area. And then the next slide will show you column K13-1. Two really important things here. One is the date. This is November 13th, 2020, about 8 months before the actual collapse. A photo was taken by the engineers, and they note a lot of water and efflorescence streaming down this column. So this is not a recent sort of crack. This has been happening, and this is a kind of chronic condition around this column L13-1, and here you can see the parking spot number 76 that I mentioned earlier. How does this happen?
All right, now I want you to look at their magical punching shear. That this column stays, the head of it is working great. All right, there's no head failure here. It's a deck failure. All right, it may not have as, a drop cap that's larger, but this is the deck being deflected. Grabbing the deck, let's call it a drape, and you just grab and push down. You create a moment here, a weight here, and it fractures upon this location here, and this is showing concrete popping off the top of the rebar. In reality, this did not look like this. We have a reality photograph of what they could show, but instead they resort back to something to get into psychologically. Hey, look at this drawing. This is what it looks like. It's not what it looks like. This thing was clean off with the rebar pointing in going in multiple directions.
There's other ways for water to start streaming down faces of column, but putting two and two together and figuring out there is a punching shear related issue with this column. Punching shear forms as kind of this slab detaching from the column. The easiest way I think to look at it, if I'm explaining to just anyone, is imagine a piece of pencil going through a piece of paper kind of deal.
Which is incorrect. All right, that's punching shear, but this didn't do that. It had a drape effect. Let me get you. So here's our column, and this is what it really comes to: column offsets. All right, the missing of the BMAs that would have been made this structurally more sound. It would have dealt with the column offsets, and this is per the code. And so Gary and the other guy Matthew have the book. They mention they have the book, but yet they're not talking about column offsets. It won't work with their narrative. It won't work with their narrative that they should have caught this a long time ago, being the owners should have. Tong Lee is the guy that I did a video on, and YouTube keeps throwing it to private, and I try to make it public. Waterproof, huge leveling deck. Why is he getting a pass? Why is Tong Lee getting a pass when he's the one that added all the fucking weight? All right, why is he getting a pass? I'll come to that in a moment. Let's go to, this is the NIST version of one of my part 1 of 3 of rectangular array again, is what it comes down to. So now let's go back to that.
That's what we're understanding here. And what can happen is it will form a shear crack, and those inclined shear cracks are shown there. And ultimately, a failure plane is developed, and through those cracks, water can ingress and then flow down. So
he understands that water can egress and expose it. Look where he has it. But look in real life, there's the water. There is the water he's mentioning coming through. It's profiled underneath this deck in the ladies walk around video. Simply profile all those cracks and then make them make sense. All right. I started doing that in a video, and then that's when I pretty much got slammed down to nothing. I'm just doing this as a follow-up for a couple of followers that wrote me saying, hey, have you seen it? I show partial of this, of the latest release. Down the face of the column. And this should have been a warning sign for those engineers that there was some punching-related distress here. The other one is a bit more nuanced. And this is a photo taken on June 2nd, 2021, just about 3 weeks before the actual collapse. And this was taken by the engineer. Let's keep in mind that I didn't have access to this photograph when I called this out. I didn't have access to this when I called the butterfly. They had access to it. They had access to this way until it was released only, a year and a half ago or so. And this just justified my belief about the butterfly and the rectangular array. About the rectangular array. This is this guy here. It's too far out of bounds. These are all, look at them, all on a diagonal. They're all offset. And the 3'6" here, another one's 6 foot up from where it should be. And they actually pinpoint where it's supposed to be in the drawing with a bullet point here. And that's the line it comes down and meets. And this is how much it's off by this direction. They make it clear that they indicate clearly how much it's offset by using come over 6 feet, 9'6" here. It's huge. Now I'm also going to show you, I'm going to reveal again that Gary Klein and Matthew Faden are amateur hours to me. They're not. They're way under my level. Yeah, I told you I said it'd be a little bit condescending. Amateur hours. All right. Between both of these engineers and their companies, they couldn't figure out this deck had an expansion joint or not. They're going to state it has no expansion joint. Let's look at the deflection, the butterfly again. Do you see it? Do you see this gate rolled over to the right away from us? Not really. It's flat. I said I would bring this up a long time ago to exist. She wanted to keep knowing about that. I said, well, it's showing the deflection. It's showing the drape. Okay, so now, and there's the drape. It goes down. We can see it. Down and down. But he's going to point from here to here. Does this look like it's draped to you? It looks pretty friggin' awesome to me. This is your drape. From this column down, from here down. You know, all the way from down. See it all the way down? And I already did a long video on this. Let's go to a couple more videos. That's a construction joint. Gary and Matthew apparently have never been on a job site that they know what a construction joint might look like. This is what a construction joint looks like. He's going to say that this building didn't have a construction joint. We know the deck sheared right there, right across, and that's what stopped it from engulfing the rest. Stopped it from engulfing the rest of the deck. All right, there's your damn construction joint. Initially, I said there was no rebar in here at one point. I got clarity, and then right there, and maybe right there, I started finding rebar. Of course, I see rebar here. So it had such great grip force over here that it was created a force multiplier and was able to fracture that rebar with no worries. Keep coming back to that, don't I? So if you look at the reveal of the gate, you see on this side of it, you see it's down. All right, there's the butterfly. There's your initial collapse. In their theory, they have it going from that one column to the one to the right, and then all of a sudden, how do they explain this? Well, they don't. They don't because they don't have the horsepower to do it. All right, again, they give this guy a pass, Tong Lee, and they were hired by the company themselves, by condo association. The homeowners couldn't hire them directly. Let's hear the rest of it.
That was working on the site, and the property manager had moved this trash can out of the way to show the engineer the distress at this planter. What you can see here is that this is again over K13.1, and so there's a large planter over this.
So the property manager, i.e. by extension, the condo association hired an expert. Their same expert that they hired to do the evaluation to come look at this. So that's the pass for the condo association, is that they hired the professional to come evaluate this. They didn't say, we're getting it done in a few weeks, let's just skip it. But on the other hand, the expert company said, we'll look at it, as I understand, we'll look at this when we come look at the davits on the roof. That's the anchors to help them lower their scaffolding down to work on the siding. We'll look at it then. They didn't give it a priority. They didn't kick ass and jump on it. They said that this was grassroots, all right, grassroots organization. That this was grassroots that pushed this over, as we recall, as we're informed. Grassroots. Now, we don't see a fracture here, which would indicate that this is falling down this way and also this way. But we do have an indication, and maybe tile repair, we got to look at that better, but we have an indication that this is sloping down here and sloping here. That this is where it's mostly feeling the stress. And it could be coming more so back from the right side also where the car loading is. Never forget that I have back here to your at the wall system where you walk into the building, I have a small fracture coming off of that wall. Coming off the wall where you go into the building from exterior, from the pool deck. I believe this is a camera light post. Of course, they don't work, right?
You can see the deflection of the bulb end of the planter and large cracks forming following the...
And their own statement, you can see how it's at a plane, and this is what they call it. in plane level is what they're drawing. And this is the deflection on this side. All right, but they're going to throw deflection here. Yet the trash can doesn't look like it's leaning over.
The deflection of the deck below. Here's a photo closer up of the corner there, and you can see that vertical displacement. This is all like.
So if we look at this, this is down and away, not towards us so much, to some degree, yes, but away, down and away. But it's critical. It's not just a rotation towards us. It's not just a rotation towards. Okay, looking at the image, counterclockwise, it's a rotation counterclockwise and the other axis going the other down and away, as we reveal in this gap.
Likely due to a punching related distress at the slab below. The interesting thing is to note is that a year before, on April 13th, 2020, there was no distress. Okay? And so I just want to take a step back and
there was no distress indicated by your imagery up top. But I don't think in 1 year we could get where'd you go? I was trying to show you the efflorescence again. It was in that image I was just looking at, the video I was looking at. I don't think we can get that there. It's in the thumbnail right there, so we're at 1758. So right here, this, see the efflorescence? I'm going to call it efflorescence issues, but it's probably not efflorescence in 1 year, that much salts, but maybe it is with salt air there. But it's like that. All right, so it is indicated below. Oops.
And this is a photo taken on June 2nd, 2021, just about 3 weeks before the actual collapse. And this was taken by the engineer that was working on the site, and the property manager had moved this trash can out of the way to show the engineer the distress at this planter. What you can see here is that this is again over K13.1, and so there's a large planter over this. You can see the deflection of the bulb end of the planter and large cracks forming following the deflection of the deck below. Here's a photo closer up of the corner there, and you can see that vertical displacement. This is all likely due to a punching related distress at the slab below. The interesting thing is to note is that a year before, on April 13th, 2020, there was no distress. Okay? And so I just want to take a step back
and again, to say there's no distress is, it would be, you would say there's no distress indicated on this planter box, but obviously distress is there, unless you're going to add a new load that just happened to come and go, such as they bought a trolling now. They bought a JGL lift onto the deck. Trolling. For you long timers, you know what I'm talking about.
People understand that punching was slowly progressing around this deck, and that's what we believe was happening. And so there is no, a lot of people have this fear that punching is an immediate trigger, and while it is it is a non-ductile failure mode, i.e. it does not give much warning, and you can see that from the...
And that's a lie. They give a shitload of warning, but are you able to pay attention to it? All right? Are you able to catch on? For example, again, that efflorescence, those cracks in the ceiling. So that's a lie. Punching shear gives a shitload of warning from everything from design, which is Tong Li overloading this deck, to maybe it's ultimately going to fail. So if I got a 40 pounds per square foot design and I put 80 pounds on it, well, there's your warning. It's going to fail. All right, there is no, it's just a matter of when. It's going long-term creep, whatever, but it's going to fail. It was only designed for 40 pounds. I'm doubling that right now, and so I'm maxing it out. So I'm going to make it, it's going to fail. Maybe I should do something. I don't know what the factor is on that, so maybe I should do, no, 40 pounds. I'm going to stick with it. At 80, it's going to fail. Because I said design 240 pounds, but not with margin.
The
No factor.
L13.1. It can progress and loads can change or can be redistributed, and that will result in giving you a little bit of time.
And then we have indicator that there was something going on here, because they did what? They replaced some tiles. So they didn't know what the deal was, and the engineer that came out and inspect this should have said, hey, I see you got fresh paint here. What's going on? Or I see you have new tiles. What are the odds are you have new tiles over my column? I need you to open this up. I need an exploratory answer, not just it's cracked, it's roots, especially when you didn't see any damn roots, right? So yes, that engineering firm should be held liable for all of that. The guy or girl that identified this as just roots should never be practicing any form of engineering again. Any form of it. It's just he or she does not have the brain power to process this. And now these guys, Gary and Matthew, also are not jumping on that too brightly just yet.
And a little bit of warning. Here is the ultimate collapse state. You can see the top.
I wanted you here. Here's the ultimate collapse. This is from June 2021. All right, so I know they're doing a current video stating that we come up with our answer, but you just said the ultimate collapse. There is no thing beyond ultimate unless you do a retraction.
Top of the planter, column K13.1 is circled, and actually I have the bottom arrow pointing at the stains on the deck to kind of show you how I picked out where K13.1 is, just using that as a reference. Other really useful information was things like the garage walkthrough videos that were present, and other videos and things that had been posted online. One of our interns spent an entire week looking at.
Did you hear his other source? Other videos, because it's only one garage video as we know, and other videos have been posted online. So he was sourcing YouTube videos, i.e. content from engineers, etc., putting up whatever he was from YouTube, posted online, videos posted online. So he was sourcing from the content, the public content like myself or other people that have put up videos on this.
Distributed, and that will.
And of course, I don't mean Tool Time. Nobody's sourcing anything from Tool Time besides idiots.
Will result in giving you a little bit of time and a little bit of warning. Here is the ultimate collapse state. You can see the top of the planter, column K13.1 is circled, and actually I have the bottom arrow pointing at the stains on the deck to kind of show you how I picked out where K13.1 is, just using that as a reference.
Is that Matthew? I think this is Matthew talking. I don't know if Gary has that voice. This might be Matthew. So listen to the source again.
Other really useful information was things like the garage walkthrough videos that were present, and other videos and things that had been posted online.
And other videos and things that are posted online. So that gives it to written forums also that he's sourcing from. So Matthew or Gary, combination, are using forums and other sources of information, not their own knowledge, but so that reveals that they're not, this report is a collage of their information that they've gathered from others posting. And I think Gary was about to beat on me one time, one of his videos, and then somebody cut him off about saying there should be a fuse at the building, calling a fuse at the building. I talked about that construction joint, but they now talk about it in the shit. And this video, I should have it queued up. Okay, right here, and this is the 1 year ago. Now listen to this. This would be Gary speaking, maybe, perhaps, but she's going to ask the question at 55:19 if you want to reference it.
Okay, were the L-shaped building wings and pool built as one structure, i.e. no expansion joints?
That's correct. There was no expansion joint.
I don't know whose voice said. No expansion joint. All right, that's correct. No expansion joint. So no expansion joint. This is the expansion joint. It came over. It stopped right here, right around 31. It's an expansion joint. So how do you? I know some of you want me to talk about this Klein videos and all that, but how can I, you know, you can call it arrogance or whatever you want, but how can I critique someone that's nowhere near my level? I mean, unless I'm trying to beat them up, and I'm not trying to beat them up. They work for the condo association. All right, they have their bias, they have their mission statement, and that's to represent the condo association. They're not going to throw the condo association on the board by stating under the bus by stating, hey, you know, we hired the condo association hired Tong Lee, and they overloaded the deck, so we should go after Tong Lee and his insurance, etc. It would come back to they were the one that caused the weight, the overloading, which they constantly talk about here, this overloading of the deck. But they forget that they put the overloading on there. They did it. The condo association did it via their professional engineer, Tong Lee, that they hired. All right, and he is the one that did the loading. All right, and then they're trying to blame it on the original design that it punching shear punched through. And I want to end this video with this. You see the fracture there? Right there? That shows that where it took a moment. And look at the plane of it. Right about there. They're in line pretty much. And that held up. That means that this deck tried to hold up under this loaded deflection from here to here. Let me screenshot it and do this. It tried to hold up. It resisted until it fractured at that point. Right here. So let me do a drawing. Let me get the drawing up for you, the sketcher. So right here shows that it had some, let's tie these together, that this plane was rigid. It was strong. It tried to hold up. But then we have this, I'm going to exaggerate down and up, right? So it was trying its best, but our deflection point is here. It tried. When it came out, the planer box indicated that stress, that it was leading in this capacity. We know that because we're looking at the ultimate failure. The real ultimate failure now is what it looks like, the deck. And there's the butterfly. All right, this was your deflecting moment. And why deflecting moment there? Why did it pick that? And probably more so back here. The loading probably started more back here. So even though we see this here, it was probably deflecting a lot more in this zone here, down here. And that's the butterfly. You can see it biasly so. You can see it here because I can come up with another reason why some of it butterflied here. And I want to talk to you about impingement or boundaries, bound. As this was going down, it was bound and it tried to slide down. This is why you get this top plate, this little triangle here, if you will, that shape there, popping off. All right, it was going down and it was, yeah, gotta get rid of that, hold on. It was bound by the wall itself and it just kicked over. And you can see everything has a reason why it's everywhere. Everything has a reason why it's everywhere exactly. It's not by accident. This rotation here, if we look at our debris here, indicates that that's the way it rolled this way. All right, down. Because this slid down the pole. All right, it broke free, it slid down the pole. On this side, we can see now that the collapse was more pushing against here, and we can see the tile stacked all the way up to the head almost. See the tile stacked up to the head? It all matters. Every piece of it will tell a story. And I already did this wall along video, so I'm not going to dive into that. And I went over this when I even talked about the rotation here of this outer one, because it made it on this side of the column, part of the planer box, and slid down, and that's the way it rotated. But there's more to that than in my longer video. It's this. It's not from here. It's not from here to here. I mean, it does have some deflection in there, but it's not great. Now, I talked about this weird fracture that's like this. Okay. I can't see that. Remember, images might be closer if it presents like that in the video. but that still indicates from here. All right, this direction. But now I can profile it a bit if I want to, and I can go like this. Actually, I should flip the arrow around, but sorry guys, I guess I should do that not to confuse myself even. And I might be taking a little bit of liberty on the length of this, so I can do that. And here's your deflection. It's here. They're literally, I mean, you can't ask for a better path. I'm going to shift that. Because I'm going to shift it over just a little bit. I'm not going to be totally biased and put it right down the center of the doorway. But, you know, this thing probably did... Oh, I can't rotate it. Shit. It probably did this. Okay? Like that. Oh, shit. Like that. Let's see if I can pick up from it. It probably did that. Something similar to that. And again, that's because the column offsets are so friggin' huge. Remember, this column is... There's a column there, the main building. It's supposed to have been somewhere about here. And look where it is. It's here. It's here, and that's the way they show that offset. And all of these guys are huge offset. This one should be approximately here. Let's go again to my drawing. Let's find my drawing. Oh, it's in the background. This thing is writing over it, as it's called. Hold on. So somewhere about the, see I have that high here, flat, and this is where I have it now over here, that gap. It shows that it shifts. Now that's the bound part where it rubs against the wall there. So this, if I could only have, you know, if they only did a survey of it, we'd be able to map it better. But it probably shifts like that. So if we were to move this one, and now like indicate with that underside of the deck there. So now you see the larger gap. This is more sagging there. We do have a load there, a car, a vehicle, TLF. Now all of a sudden we're getting more like, okay, so I got to delete that one. So you're getting more like, so, you're getting more like, well, it looks like I can't get my arrow up. Can't get it up, guys. Okay, so maybe more like that, but it's still justified because of this. The huge offsets. And I hope I have it ready. These huge ass offsets. Look at it again. 6 foot over. Planter box is right about there. Planter box, it's a 6 foot. It's supposed to be there. Let's drag this back over, and then I'll go and grab the image again. So 6 foot right about there. Let's see the bumper of the car. I just extrapolated. I'm probably off a bit. But now let's go use the white bumper of the car I showed you in a moment ago. White bumper of the car. The column is forward of that bumper of the car. There's a column there. Let's grab the column again. Okay, remember the column aligned with the car. Column aligned with the car. A little bit of compression makes it pull forward a bit, but it looks like it's more in plane behind the car. Just a nibble. Sorry about jumping. Our tabs aren't that easy to access. Here's that column, and the car is right about there. Lo and behold, we follow the column out, and that's where the deflection of the pool deck, the deck is during failure when we see that planter box. Following let me get this correct again. Yeah, my brain just got flipped upside down. Sorry, guys. I had to invert everything again. So car spots, parking spot. And here's the white car, let's call it. And it's set back just a bit. And there's the column, and we follow it over, and now we get that gap. Boy, oh boy. And now we get that gap. That's where a column should have been. All right, or the BMA rather should have been there. Remember, this is about the BMA would have been supporting at that location, the beams. So now let's go ahead and clean up this mess. Let me clean this up. Great. But this is the true butterfly, and the BMAs would have supported this deck. That also reduced the thickness of the deck. Remember, from 2'10" down to 1'10". As it been mentioned in the report, not in the previous Klein report, not in this, I have not finished this current report, but not in this current report as of now. I said I'd go over it live video. I've only made it this thus far, but this is their updated version. And is the updated version? Yeah, this is the updated version. Yeah, this is the updated version. I'm trying to find a good date for you on this. I know it says 2021 there. Be careful of the halo effect. Remember, if you look at these two guys and you would try to judge them, which one looks more attractive, whatever one you find more attractive, you're going to state that that they're more knowledgeable. It's just the way it works, guys. So be careful of the halo effect. So Gary Klein, being an older man, has, the suit on, presents more healthy, even though he's fatter, if you will, than the skinnier guy that should be more healthy. Gary Klein presents this halo effect. This is everything psychology. Presents as a more intelligent person just because of his extra weight, tie, the way he presents better. My buddy over here, Matthew, has the thinner neck, the loose collar. It's just weird, this halo effect. You've got to be careful of it. Looking to the right, attractive woman, hair behind her eyes, and she's doing material evaluation. I'm not sure if that would have been the best way to show her with her skill set, especially since she's actually performing in a lab without glasses on. And this one is, because they show up at sites, this one is, I'm looking at a building and it's fire damage. She's sort of standing over it, taking the thing on it. The and she's contaminating the scene by being there herself. You want to take as much data as you can before you start contaminating the scene. And maybe they did. So okay, with your footprints, etc., is what I'm driving at. Even though the firemen and everything else might have been already through there. This video still has a lot more time in it. I'm going to end this one because this has a lot more time to go over. But I wanted to show you that he said that no to the construction joint.
L13.1.
Oops. This will be that one. It would be this one. Nope. Yes. Nope. That's me again. Yes. We'll back it up just a touch.
L-shaped building wings and pool built as one structure, i.e. no expansion joints.
That's correct. There was no expansion joint.
Okay. So that's the experts from the Champlain Towers South Condo Association stating no expansion joint. That should be enough right there to discredit the person's knowledge. All right. Now he can come back with, oh shit, I have to do a retraction. I now waking up, I see the expansion joint. All right. So hence the fuse, which Gary talked about in that video, saying that someone online was talking about it should be an expansion joint there at the building. And I still agree to that to this day, that all these buildings were pool decks that are also pool decks and also garage decks should be considered bridges. They should be inspected every 2 years, and they should be required to be separate from the building, the home connected to it. No more than you connect a freeway to the homes that they go through in cities. Should parking garages, pool decks be connected to the homes, the condo, the building it's connected to. There must be a new law that comes out that states that the separation will take place, period. And that these are not only bridges, because cars drive on them, but they also are parking decks also. They're doubling as a bridge and parking deck. It's ludicrous to be doing this, all right? Connecting your bridges to homes, to the condos, and expecting the bridge to be okay when the bridge fails, expecting not to affect the home. All right, you've got to make that expansion. You've got to have that walkway, that separation, where it can free fall. The bridge, the walkway, and the gangplank would be how you would enter the structure then. To enter these buildings, yes, you're going to lose real estate, but you're now going to have your parking deck and your building separate. Especially when it comes down to, say, for an example, an earthquake. There's the rattling of it. You're creating this table down low that could help undercut your main structure above. That I'll leave that to Professor Dawn Lehman and her school to see that, to visualize that. All right. Thank you for supporting the channel. Got 2 new cats outside I'm taking care of. No, I'm not bringing them in. I'm doing my strongest. I got one that lives underneath my house now. I was out there clearing out some stuff. I've been throwing away stuff like crazy, guys. I've been getting rid of things like wild. I've got a bunch of steel that I've got to get rid of. But I've been getting rid of things. And I was cleaning out my underside of this large deck I have that's enclosed. And comes out the little cat. I've been seeing him a few days and I've been feeding him, but I was making a terrible lot of ruckus under there. And he came out out of nowhere. I was like, whoa, that was you. He was playing possum for some time. And I like ending with a joke. So or telling jokes. Here's my last joke. I came up with this one yesterday, actually. Someone threatens to beat you up, right? And I just go into freeze mode. I just freeze my whole body, tongue hanging out, head leaning, arm frozen, and you just keep still. Of course, the person, what the fuck are you doing? What are you doing? I'm like, I'm playing possum. Just go play possum on him. You know how possums could all of a sudden just freeze and that's their protecting mode. Just tell them I'm playing possum. Now you can't see me. Anyway, imagine if someone did that in real life. That would have to crack up the person that was wanting to beat you up. That would have to make for a good joke. Be like, oh my gosh, that's the best. But you're taking a risk that the person doesn't just slug you, but it's got to be for fun. So there we go. So yes, I don't really want to beat up WJE, but they're so easy. All right, he's not claiming he's the source of almost any data. He's claiming that the source was from YouTube and online forums. All right, so they're taking other people's data. They presented it in court, and now they're presenting stuff like this, and it's wrong. It's wrong. This butterfly is this way, not the way they present it as going from. Oh shit! I didn't finish it, did I? Going from K to L. K to.
The one thing I also want to mention in this slide is beam A. Beam A is shown here. It was shown on the original structural drawings as well. It's unclear
and he's calling it beam A. As the original structure drawing says, it's BMA. I know that he wants to say, a lot of people want to say it's B and an M and A is where you get your beam A. Nope, they have in the drawings beam type A, beam type whatever, and they have a size where you can find it. This was, BMA is from NIST, and it is a post-tension member. Shit. I did not want to do this. Now I have no choice. Maybe I'm the only one that can still find this. BMA. Shit. And NIST. Let's see if I come up. Yeah, so here's my BMA. Here's my BMA. Okay. So let's see if I can
Good morning, people.
scrub it real quick. If I can scrub. Sorry, guys. I'm not. Got one of those wireless mouse. Sometimes dust can make it go crazy. The illusion of truth, also known as illusion of truth of fact, is the tendency to believe false information to be correct after repeated exposure. All right, this is some serious stuff. You keep getting the same exposure, such as beam type A, you'll start believing it. But yet NIST has a clear, makes it very clear. There's the fracture again. There's the rotation the other direction. Makes it very clear that BMAs exist. There it is. A BMA under NIST document here. All right. The connection details vary from post tension with 2 post tension bars. BMA. It's not by mistake. This drawing says BMA on it. He didn't say beam type A, BM-A. He said BMA, and yet Klein and this other guy can't figure out, and all these other engineers, let's make it clear, including NIST so far, even with their own friggin' access to the report, can't figure out that BMAs existed. They existed then, they were tested then. In fact, look what this one's called. A connection using 4-threaded rebars called a BMB rather. A composite connection, a BMC, consisting of a CIP topping and a precast beam with a post-tension bar. A welded connection, a BMD. A bolted connection, a BME. A connection with 4-threaded rebars, which were threaded into couplers anchored into column, is a BMF. A connection similar to connection BMF, with the difference between the use of tapered threaded splices, is a BMG. And then specimens, BMA through BMF, and let's say that's through, that says dash, where exterior connections and specimens. BMG was an interior connection. All right, so now we can prove these are exterior. That was an exterior connection. All right, and BMF is the interior connections. So BMAs exist. So to try to change its name to beam type A, and maybe that one did call beam A. I don't quite remember my coconut just yet. But there are BMAs here.
Detailing was very unclear. And so seeing that in this image is also extremely helpful for us in our understanding of the as-built conditions.
Let's make it this far.
Another video that is really helpful in our understanding of the kind of timeline of the collapse is this TikTok video. And this TikTok video was taken by somebody staying at the Blue Green Resort just to the north of.
I'm not going to go. This is another video altogether. I could have fun with, learn a lot from you guys on this first, and then we'll go from here. But I want you to know what BMAs exist, all right? They really, literally exist. This call for BMAs, it's a different beam, different type of constructed beam, a BMA. So please don't, he did mention beam type A inside his drawings. He did mention that, beam, BM, and then type, all right? This is BMA. There is literally a difference. And we know this person changes his drawing details because he did. When he bumped out the kitchen area in the other part of the building, he bumped it out by 5 feet. So he did a lot of sneaky stuff. Remember, this was self-certified by the engineer and architect. Could self-certify, must self-certify there because the municipality was not signing off on it. And then he even snuck an entire floor on top, or a penthouse on top, if you recall. So don't think that this person is sweet and kind, that, we can just trust what they did. They didn't. They removed the BMAs. They offset these columns huge, right? The column, they removed the BMAs and left the offsets for parking. For parking reasons, they left the... Oops. That didn't work. For parking reasons, where are you, sweetie? Bear with me. Yeah. So this was supposed to have all types of columns between it. Let's see, I'm in my, okay, let's go over here and just do that. Let's just back out of it. Sorry guys, the color of that tab looks the same as my other color. Right, there's a connection to BMAs. All right, where's my sweeties? There they are, right there. So this was supposed to have a 12-foot 10 elevation, 2 foot 6 elevation, sorry. And I think it's 12 foot 10. They dropped it to 11 foot 10. They made them even, but this was a 2 foot 6. This is a huge reduction and stability, as I like to call it. What did I call it? I used it as it's known in Asian countries, etc. Plinth beam thinking. For you engineers out there, just look up plinth beams, the highest beam above grade, and so you're like, huh, I could see where that would work. Let's think from there, where you could understand it as a plinth beam. See this? It says BMA, so it is a BMA. It's not beam type A. It's BMA, BMA, BMA. All right. And it was yet to be designed. Here's a step down, 1 foot step down. This was where the parking garage area was to be. What was, and here's another BMA here, right between it, from here to here. All right, and this is all the loading for the parking area. If you notice, it's all loading for the parking area. Here's the pool deck loading area, and the BMAs would give it more rigidity back here, along because you're going to do a reduction here. This is a ramp, auto ramp coming here. So this is 1 foot over here, but this is 1 foot 6. But you have to do this. The reduction is changed. The height is changed. So it's even thinner here. Thinner in depth height. It's 2 foot 6 back over here. All right, 2 foot 6 here. It's less here because of that step up deck, and then step back down to the pool deck, and that's 1 foot 11 inches. It steps up, and then there's another 7 inches. So it's thinner over here between here and here, and so the load path is sort of like this, wrapped around. It's got some rigidity from this BMA. It comes across this 1 foot 11 inch elevated beam, let's call it. See it right there? Upside down beam on top of the deck, and then it's back into the BMA combination. Maybe it's sitting on top, so maybe now we lose some rigidity because it's on top and not below. So it's trying to grab like putting 2x12s on top of a post instead of inside. It loses its racking ability. And same thing here, and then it wraps back down. Now it comes back to the building, and 2 foot 6. Between there is some slab, right? The slab, this interior slab, that gives it its rigidity across there. But out here, they also slipped in a switcheroo, the change. That's not 2 foot 6. This is not 4 foot anymore. This is 5 foot. I believe it's 5 foot. So this also rests on a BMA here, and forget what we're going here. But this is that H beam, as I called it, referencing it. But in reality, H beam is extended out to here. It's connected. They're inter-designed, and that tells you a lot about the deck design when they built the deck and the structure here, because the reinforcement through here, and especially this one would tell you how it is, because this is poured as one here, coming across and tying wrapping it, sitting on top of a BMA, and there's another column. This beam 35, I have to give a shout out to my man in Pennsylvania. What's his name? I tried to pull a bluff on that one about, look at this beam in the way here. And Tool Time went for it. He made a whole video on it, and I laughed, busted Tool Time about there's a column here. And some of the other forums went all with it. Well, it can't be a column there. The cars go through there. It sits on top of this damn beam. So Tool Time came over here, snatched it up, but he didn't catch on that my man, he busted me in the video that I tried to do one of my Columbo moves on. He busted it within, I was doing a live video. He busted it within 10 seconds. No, that can't be there. The car's there. I'm like, Jamie did it. I was like, Jamie just killed my Trojan horse, my trap. But obviously he didn't read Jamie's comment, because a few days later, Tool Time put a video out about this column being here in the down below. 2 times is just a phone engineer, guys. I know he keeps telling everybody he's an engineer, but he's a phone engineer. No more than a computer engineer would be dealing with this. And some computer engineers I have noticed on the forums are pretty smart. I give that out to them, so I'm not trying to retract that. Even though they may be haters on me, I still think when I've seen a couple of their posts, I think some of the computer engineers are, steady computer engineers are pretty, some of them are pretty intelligent. So I give them an A for that. And maybe that's because they're working outside their wheelhouse. They have an open mind like a child, and they can see things a little differently than the people stuck in a box. I've already talked about this when we get to the failure of the building, that the original engineer, knew that something was up here, and he wanted to increase the critical shear zone here, 18.5, 17.5s, compared to 16.5s and 16s. See it? And then on the far right, he went to 18.5s again and 16.5s. But he had something going on here. And remember, the critical shear zone here is only like this. This is a step down, so he cannot engulf it like this. So that makes a weaker connection, but you get some deduction for not having the concrete across, right across from it, and no rebar. Oh, wait a minute. There are steps there, and it's a step down, so it does create a side loading on this column and 2 points. So it'll be creating side loading and top loading at this column here, because it goes up through the building, and also side loading a little bit lower, so side mounted deck. The deck is side mounted to here with a 1'6" ledger beam, let's call it 1'6" ledger beam, as opposed to 2'6". I'm going to end this video, and I just want you to realize that once you remove these BMAs and you load it with the car decking, yes, you get weakness, and there's this column right there. That's the one. That's the 6 foot up. That's the one. It's the major part of the building. It's supposed to be that's right there. If they'd have kept that 1 foot elevation, especially if the engineer would have called alert when it came down to checking that box out, if you'd have said, no, we need temporary shore this bridge, what I call a bridge out here. Everything out here is a bridge, with standing on beams and columns, but not disconnected from the structure. So you have your bridge, which is not connected to bridges around the world, aren't connecting to the main building. You want vibration, reach no further than your bridge being connected to the building. Cars coming here, vibrating here, causing frequency in the steel, weakening it here, which of all odds, what are the magical odds that he takes a core sample there and it comes back like shit, fractured up? And he cut the rebar, and he did not put it back per the engineer's requirements, that you cut through that rebar, that you better make it whole. As I understand, it was never made whole again, meaning back structurally sound, and over here also. Ending video. Love you guys. I hope this wasn't too long of a video. Control joint. So that's enough right there to shut down WJE. That is a control joint there. All right. You can come to his video on YouTube at 55:19, 55:19. Right here, 55:18.
Okay, were the L-shaped building wings and pool built as one structure, i.e. no expansion joints?
That's correct. There was no expansion joint.
Okay. All right. So what are we dealing with here? WJE hiring people that just look good and not really understanding it, or out of their depth, or not. So you either don't know it's an expansion joint there, or what? I mean, come on. I'm done with this shit. Take care, guys. So when you tell me to come look at here, I'll look at it. But remember, I'm looking at someone that's subgrade. All right? That's just, I don't know what the hell they're doing. You know, is it purposely done that way, saying no expansion joint? Or is it not? But I will say, let me end it with that. Gary did I think he was alluding to me about the fuse next to the building, and someone cut him off with another question. He didn't come back to it. He's talking about a YouTuber talking about the disconnect, the fuse. Let's keep in mind, Tool Time, after I did that video, also then came along and tried to redid my own work in a video talking about that. So, of course, we just timestamped that, and you look at it and you see that I've been talking about that first. And then all of a sudden, he goes on vacation, as I recall, because somebody said, he's stealing your work again. And he shows, look, there's an expansion joint here, a control joint here. And remember, this guy doesn't know ass from hole in the ground pretty much. He probably got that figured out. But I saw his deck video. It shows he has not a clue about decks, about how load path works. He had an engineer on there, structural guy, that also was dropping the ball about load paths on a wooden deck. I would show you that video, but you know what? That waste my energy on some guy who's just trying to profit off of YouTube and just take other people's hard work, including he takes from other forums. He takes from a forum called You guys know which forum I'm talking about, the green one, the green label one. No brain. But I've seen people on that forum also watch my channel. They'll write me saying, here he is again. And they'll write me, and I won't ever give you up. I won't ever give you up. Who would write me, and they'll send me a link, and I'll look, and I'm like, yeah, I don't have time for that. So I'd rather just say that, you know, let him disclose his which he's already done, that he's a cell phone engineer from back in the day. And it's got nothing to do with this structural stuff, guys. All right. Love you guys. And so this is the same thing here. Gary and Matthew, maybe they are structural guys, but they're, lower grade. NIST uses lower grade engineers also. So they would qualify for NIST. And remember, these people were hired from to represent the condo association. So take everything they say with, well, you can discredit them with what I just told you. He said no construction joints, and I showed it to you. And we talked about all this other goodies. Love you. Bye.